So, hello and welcome to our third lecture in the fall 2020 Bioinformatics Bootcamp called the Tidyverse. So the fundamental purpose behind using the Tidyverse actually relates back to the rationale and the philosophy behind data analysis. So we can actually break all data analyses down into a discrete series of repeatable steps. And this is one way to consider that. So, So every data analysis is going to follow this pattern. The first step is always going to be to import your data. That might be in Excel, that might be, opening, opening a file or pasting in some data from Prison. But however you do it, you're going to be importing the data first. Then you're going to tidy the data. That means getting it into the correct form so that you can process it and analyze it. You're going to transform the data. This is really the main analysis component of the workflow. So this is where you're doing all the transformations and analyses necessary to get your data into a form where you can make sense of it. And probably the main way we're going to do that is by visualizing it. So this is where you actually create summary plots and in some cases summary tables in order to communicate that data. So that's the typical workflow that we go through when we're analyzing data. There's another step here called model, which we're actually not going to talk about today. But this is often the case where you discover something new or interesting or find a new pattern when you're analyzing your data. And so you want to go back and you want to model that phenomenon and then understand it in greater detail and ultimately communicate it. But for most of our typical data analyses, we actually aren't going to use that step. Tidyverse is a suite of R packages that are really well designed to accomplish all of those goals. So we can actually see here overlaid some of the most popular Tidyverse packages over top of those data analysis steps. So today we're actually going to be talking about just a couple of these. We're going to be talking about readr for data importing, dplyr for transformation and analysis of data, and then ggplot2 for your data visualization. So I'm going to jump right in now to getting started with Tidyverse. So, like anything else, whenever we talk about how to do something in R, it's useful to have a goal in mind. So in this particular case, I found this really interesting data set called Titanic.csv, and it contains information about the passengers who were aboard the Titanic, and includes information such as their sex and their age, and then as well as their sort of socioeconomic status. How much did they pay for their tickets of the fare, or what class was their ticket? Was it a first class, second class, or third class? And kind of the point of all this is you can see here we have knowledge of whether or not they survived or not. And we're kind of curious whether or not these factors can be used to understand who's going to, or to predict who's going to survive and who's not going to survive. So it's something that we might analyze in the context of machine learning, but it's also a really good example for just understanding data analysis in general. So to get started, the first thing we do is we install these packages, Tidyverse and ggpubr. So again, this is the first line of your notes. So just to reiterate, all of you should have this week 4 notes.r open in front of you. Just in case anyone came in late, this is in the box folder, and I shared the link in the chat. So make sure you have this open in front of you. This is corresponding to the very first couple lines of code here. So go ahead and run that if you haven't already. Okay, so once you do that, you're actually able to load the Tidyverse package. And the Tidyverse package, you can see here, it'll tell you a little message. It tells you basically the Tidyverse package contains these packages inside of it. So it's not only loading Tidyverse, but it's actually loading ggplot2 and purrr and dplyr and a few other things. So let's now talk about the first step, which is the data import step. So we have our data. It's in a CSV file that's actually being hosted online, and here's the link. So again, if you come in here to your notes page, you can see this is written right here for you with the correct link in place. So when we run this, what we're doing is we're reading this CSV file into an R data object. And we can actually see that object here. So when we print that to the screen, it'll tell us that it's a tibble. And it shows that it's 891 rows by 12 columns. And so one of the things that's important to notice here, this is the Tidyverse way of doing things. So instead of having data frames, you have tibbles. And while under the hood, they're actually quite similar, tibbles have a few things that make them more convenient to work with, especially when you're doing a data analysis. So in this particular case, you can see that when we printed this, it's a nice user-friendly print statement describing not only what are the column names in the data, but also what data type do those columns correspond to. So passenger ID is a double, which is another way of saying a numeric in R. Survived is a double, 0 or 1. P-class is a double. Name is a character, and so on and so forth. Okay. So now that we've got the data, we can actually skip the tidy step because it's actually already in the correct format and move right to transformation with dplyr. So the first thing we might want to do is we might want to filter our data set. So in this particular case, as an example, I'm going to show you how we do that using dplyr's filter verb. So the first thing we do is we take our data and we pipe it. And that's what this is called. It's called a pipe. And that's basically a way of sending our data to some function. In this case, we're sending it to the filter function. And we're saying, I want to filter based on some criteria. So basically what I'm saying here is I'm taking my data, I'm piping it into filter, and then I'm filtering it based on the criteria that age should be greater than 12. Age, of course, being a column in my tibble. So the ultimate result of this is that we are only going to keep the rows where the passenger's age was greater than 12. And when we run this, we can see the output. Now we only have passengers who are over the age of 12 in our data set. So this is a little bit different from how you're probably used to interacting with R at this point. This is really a different vocabulary and a different style of interacting with the data. But ultimately, this is more efficient, and I think you'll find that it's more user-friendly at the end of the day. If you have any questions, also, feel free to ask them in the chat. We've got TAs who are here to help you, and especially if it's something more conceptual in nature, I'd be happy to stop and explain it. Okay. So another verb that we might want to use is the select verb. The select verb allows us to pick and choose the columns that we want to keep or remove from our data set. So let's say that I wanted to only select the columns survived and sex. So if I run this, now I can see that I only have 2 columns instead of the original 12, and all I have now is survived and sex. And we're also still applying our filter. So this is part of why we use the pipe, because it allows us to chain together multiple commands in dplyr. So first we filter saying age should be greater than 12, and then we select survived and sex. So McKenna Wallet asked, will this alter the original Tidy Titanic when you select? So no. And this is actually a nice general rule for R. Whenever you run a command like this, it's not going to alter the original object unless you reassign it back to the original object. So if I took all of this and reassigned it to Tidy Titanic, then it would. And actually, I can show you that here. So we're on this line right here. To actually alter the original object, I would have to take all of this and then reassign it back to Tidy Titanic. And now I'd be overwriting the original object with the output of these filter and select statements. But if I just run them as is without reassigning it, then it's not altering the original object. It's just performing these dplyr functions and then outputting the result. So I can see when, oh, right, I didn't run the things before this. My bad. So when I run this, I can see that it gives me the same output, but if I look at Tidy Titanic, it still has all of its columns and all of its rows. So it hasn't altered the original object at all. So we can see here now that when we do the select, we only have the columns that we selected for. Another really important verb to use in dplyr is called group by. So group by is going to take your data set and it's going to assign groupings. And this is actually a property of Tibbles that makes them different from data frames. And I think you'll see in just a second how that's working. But so let's say in this particular case, I want to group by sex. So I want to group my male or female. And then I want to group by survived. So I'm now asking to group my data by male or female, and then by lived or died. So we can see this here. Now when I print this to the screen, the tibble hasn't been altered at all. It's still got the same number of rows and columns, but now we've added this extra line, groups. And it says here we've grouped by sex, and then we've grouped by survived. And it says we have 4 groups. And that's because you've got 2 sexes, and you've got survived, yes or no. So 4 groups. So why would we really want to do this? Well, there's actually a really good reason, and it's because this now allows us to perform summary statistics. So this is now probably one of our most important verbs that exists in dplyr, the summarize verb. So we've made our groupings, and let's say we want to ask the question, right? Perhaps I'm thinking that because there's this old adage from I suppose the past maritime philosophy that when a ship is sinking, you're supposed to save women and children first. So perhaps I'll make the maybe I'll make the prediction that sex will predict survival. Perhaps there were more women surviving than men. And so now I want to actually put that to the test. I want to group all of my data by sex and then survival. And then I want to count, right? I want to count how many women lived, how many women died, how many men lived, and how many men died. And I want to see if there's any difference between these. So now that I've made my groupings, I can use summarize. And in this summarize statement, I'm actually going to use n, which means count. That's a way of saying count in dplyr. So I want to count the number of members in my 4 groups. And I'm going to assign that to a new column, num_sex_survive. So don't worry if this is really confusing at first. Honestly, this is probably the hardest part in all of dplyr is understanding how the group by and summarization works. But I just want to give you the intuition of what it's doing. So what will this output? Well, this will output a table containing my 4 groups as the 4 rows, So women who died, women who lived, men who died, men who lived, and then counts of the number of passengers in each of my 4 groups. So we can see here that there's 51 females dying, 178 females surviving, so on and so forth with the males. So this is already really getting me to my question, which was, were there more women surviving than men surviving? And we can see here already that when we look at the female survival, it does seem to be higher than the male survival. But we might say, well, this is probably not a super fair way to look at our data, because really, ideally, you should be looking at the percentage of each sex surviving, not the number, because the number isn't normalized to the total number of individuals in that sex. So we're going to actually calculate that percentage now. And yeah. So yeah, what is the percentage of females surviving versus dying, and then for males as well? So to do that, we're going to use the mutate verb. So the way the mutate verb works is it allows us to perform a calculation and assign the result of that calculation to a new column. So in this particular case, we're going to mutate, and we're going to calculate the num sex survive, which was our counts, how many passengers were in our 4 groups, divided by the total number of passengers in that group, or sorry, in that sex, and then multiplied by 100. And that should give us our percentage of each sex surviving. And so we can now see that here. We can see our new column has been created, PCT_sex_survive, and it's got percentages of females dying versus surviving, and males dying versus surviving. So we can actually now kind of fairly compare the male and female survival rates. So a really important point to understand here, which I really am not going to do justice. Hopefully, when you start to work with this more, it'll start to become more intuitive what I mean by this. Yeah, that Simon just asked the question that I was about to answer. Right, so very well put. How did the sum function know to only sum the 2 rows corresponding to the sex rather than all 4 rows, right? So let's see here. Yeah, so basically what he's asking is, how come when I did this calculation, right, I said num_sex_survive divided by sum of num_sex_survive. So why was that dividing this by the sex rather than by just all of the values in this column? And let me make that a little bit more plain here. I think I perhaps even have an example. Yeah, right, I forgot I totally made an example here for this. Awesome. So the first question is, what is the sum function actually doing, right? So if I have a vector of numbers, and hopefully you're still following along at this point, I'm on line 47. So if I take the sum of that numeric vector, well, it's going to count up all the values in that vector, and it's just going to add them up. So 14, because that's 1 plus 5 plus 8. And then if I said, well, what proportion of that total vector does each element comprise? Basically, I'm asking if I divide 1 by that sum, 5 by that sum, and then 8 by that sum, well, that would be my proportions. So I can see that, 0.07, or I guess it's about 7% is made up of 1, 35% is made up of 5, and 8% is made up of, I guess I said that backwards. 5 makes up 35% of that total sum. 8 makes up 57% of that total sum. So I can actually see that as percentages if I multiply by 100. So that is how a sum usually works. It's going to take a numeric vector, and it's going to add up all the values in that vector. And if we want to calculate percentages, all we have to do is divide that numeric vector by that sum statement to get our percentages. So this now brings us back to our problem, which is how then is it possible that when we did our mutate statement, how then is it possible that we were able to get the percentages with respect to each sex and not with respect to the entire column, right? Because when we did this num_seq survive, which is this column here, divided by sum of num_seq survive, it actually calculated, it did 51 not divided by the entire thing, but 51 divided by the sum of 51 and 178. And the reason it did that, the reason it works, is because of our grouping. We're still grouping by sex. And because we're still grouping by sex, when I do my summation, it's only summing within groups. So it takes the sum of 51 plus 178, and then separately takes the sum of 344 plus 72. Yeah, Joel said it actually. Yeah, Joel got it. Right, so when I do my division, I'm actually not dividing by the sum of this entire column. I'm just dividing by the sum of this entire column with respect to sex. And I'm doing that individually for females and then individually for males. So if I'm looking at, just going down the list, if I'm looking at the 51 element, I'm really only dividing it by the sum of 51 plus 178, because that is my sex grouping for 51. It belongs to the female sex, so it only gets divided by the sum of all the female sex. And that's why my percentages add up to 100 for females and for males. So, so Simon asks, so this means the order of columns in the group by function is really important then to determine the hierarchy of groups. Exactly. So I'm actually going to go back even one more slide. So remember when we did our grouping, right? We grouped by sex and then we grouped by survived. So one of the things that's really unique to dplyr, and one of the things you kind of have to keep in mind when you're using dplyr, is that when you do a group by, well, if you then proceed to do a summarization, and we can see this here, you actually lose the last group in your groupings. So while it was originally grouped by sex and then survived, now it's only grouped by sex. And you can actually see it gives you a little statement telling you that it's doing that. It says summarize regrouping output by sex. Override with .groups argument. So you can actually keep it from doing that. You can prevent that. But the point is that as you're doing an analysis, typically dplyr's philosophy is that you're rolling up your data. You're kind of slowly rolling it up. And what that means to dplyr is that every time you do a summarization, your last group gets chopped off. You peel away your last group as you roll up your data using a summarize. And I know that probably doesn't make a lot of sense, especially if you don't have a lot of experience with analyzing data with Tidyverse. But I think the more practice you get with it, the more intuitive sense that's going to make, why it's doing that, and how that's actually typically what you want as you're doing an analysis. So, okay. So that means that by the time we get to our mutate, we have only our two groups left, and those are what we use to do our summation. And that's why we can do our percentages within each sex, because those are our two groups which still remain. So hopefully, again, I know that's really confusing. Hopefully, as you get more practice with it, I think you're going to find that that starts to make a lot more sense intuitively. So let's say that I wanted not just to see that what I wanted was not to see the percentage of those who lived and died. I just want to see the percentage who survived. Well, the way I could do that is with another filter statement. So now I'm saying I only want the percentages of survival. And now we can see we only have now our two rows, females surviving and the percentage of females surviving, males surviving and the percentage of males surviving. So now we can do our direct comparison. One of the ways that you can use this more practically is you can save the results of this analysis in a variable. So in this particular case, I'm saving this in the variable pctserve. And when I print that to the screen, I can see it still holds all the results that I showed previously. Okay, so I think that's quite a lot. Let's go ahead and do our first hands-on activity. Again, you should have the notes open in front of you in RStudio. The first hands-on activity is in the notes. So if you come down here, you should see hands-on activity 1, and I'm going to give you 15 minutes to go through that. It uses the mtcars dataset, which is actually native to R, so it's already loaded into R. And when you view that, you can actually see it here. So go ahead, do this first hands-on activity, and then I'll come back in 14, 15 minutes. And also do feel free to keep asking questions in the chat if you run into issues. Okay, so let's go ahead and go through these. All right. Something really useful to keep in mind that I probably should have mentioned is that if you go into the box folder for the course, you can actually find there's these resources here, and they include cheat sheets for a lot of aspects of R programming. And so if you look here, there's actually a dplyr cheat sheet and a readr and tidyr cheat sheet as well. But this one's probably the most useful for right now. So this actually describes what we just went through with the different verbs in dplyr. And I think this is just a really nice reference to have when you're trying to solve problems like these. Okay, so I'm going to go through the answers. So for the first one, I said filter empty cars for cars where sil is 6 or more. And so to do this, we just use the filter verb. And so the sil column is the number of cylinders. And so we want the number of cylinders to be greater than or equal to 6. So if we run that, we can see now the resulting table only has cars with the number of cylinders greater than or equal to 6. All right, so the next one said to select the disp and WT and MPG columns. So that's just a simple select statement. So we're going to select disp, weight, and MPG columns. When we run this, we can see now we have a table that only has these 3 columns in it. Okay, so then I asked you to group empty cars by the number of cylinders. So that's simply the group by statement. So we run that, and we can see now that we've got a table with groups based on cylinders. It says there's 3 groups because there's 3 options for the number of cylinders. So this was now getting a little bit harder. So I said to add up the number of cars in each of the cylinder groups. And so I didn't talk about this in the slides, but if you were looking at the notes, you probably saw there's actually a really nice shorthand to do this, which is just the tally function. Tally. But if you didn't see that, then you could simply have used summarize. Summarize. I'm going to make it American out of despite Simon. Summarize. And so I could say that the number cars is equal to n. And so it's the same thing now, but it called the column name and the new data frame num underscore cars. And again, if you have any questions about what I'm doing here, do feel free to ask in the chat. It's going to be a little bit complex for the last couple ones. So I completely expect that people are going to have questions on those. Seriously, don't be afraid to ask. I'm sure a lot of other people have the same question, because this part is pretty difficult at first. So then I said to calculate the medium weight in each cylinder group. So we still need our group. We still need our group by. And then we're going to now calculate the median weight in each cylinder group. And this is actually a summarization. So what makes a summarization different from a mutate? Well, for a summarize, you're actually collapsing your data based on a grouping. So we want to collapse our data based around our grouping by cylinder. So we're doing that using the summarize command, and we want to make this new column median weight. And in R, median is just median, and we're asking the median of weights. And now we can see here we've managed to correctly calculate this. So just like with sum in the example that I showed in the slides, median is calculating not the median of the entire weight column in our full tibble, but it's just calculating the median of the weight column based around each group, within each group. So we've got now the median within each group assigned to our new column, median underscore WT. All right, so now I asked create a new column which contains the ratio of horsepower to mpg and only keep the cars with WT greater than 3. So I actually didn't specify which order you had to do these in, but I'll just do them in the order they appear in the problem. So to create a new column without summarizing, we just use mutate. And so we can call our new column HP ratio, and it's the ratio of horsepower to mpg. So that's how you would create that new column. And then I said only keep the cars with WT greater than 3. So that's just a filter statement, filter WT greater than 3. And now we can see we've created our new column, HP ratio, and we filtered it so we're only keeping WT greater than 3. So only the rows where WT is greater than 3 are being kept. Finally, this was probably the hardest part of all of it. I said to group by gear and then find the average HP to WT ratio. So this one actually required you to by hand write out pretty much this entire thing. So the first thing I do is I get that HP ratio, just like before, HP divided by mpg. But now I need to group it by gear and then find the average. So if you're kind of understanding the difference between summarize and mutate, you'll probably recognize that at this point we need a summarize statement, because we're now collapsing our data around the groups and finding the average of this column. So this is our summarize, and I can just call this new column average HP ratio, and it's going to be the mean of the HP ratio. So this is probably the hardest part. There's some practice problems that I'm going to give you that you'll also get from DataCamp that are probably going to give you the intuition as to why this works. But just so you know that it actually does and kind of how you would do that analysis, you can see it here, and we get our result, which is our average within each group, the average horsepower ratio. So that's horsepower divided by mpg, or HP divided by mpg. Okay, so before we move on to the next part, does anybody have any questions? Okay. So Catherine said she didn't add the mutate line. Is it necessary to? I mean, if you got the right answer, I mean, I'm probably doing this in not the most efficient way. Do you want to share how you did it? Yeah, that also works. Yeah, so the way that Catherine did it, which is actually even more efficient than what I have written here, is like this. Let me share my screen again. So the way that Catherine did it is like this. So rather than using this mutate statement, she actually incorporated the HP ratio calculation into her summarize. So instead of doing this mean of HP ratio, she actually did the HP ratio calculation inside of mean in the summarize statement, which is, yeah, that's really good. That's actually a much more efficient way than what I had. So yeah, very good, very good. Okay, are there any other questions or comments? Oops. Doesn't seem to be able to see the chat anymore. Oh, there it is. Oh, Yeah, I'm sorry, I misread it. Yeah, you're right. It does say HP to WT, not HP to MPG. So yeah, Hannah just made the point that it's HP to WT. So it should have been like this. And then I guess, Catherine, yours probably would have been like this. My bad. Thank you for pointing that out. Yep, I wrote this and then I misread it, which is, that shows my the degree to which I pay attention when I read things. Why do the groups seem to all have the same gear number? Okay, I'm confused. Do you mean this here? 3, 4, and 5? Okay. Okay. All right. Good. Good. So, did anybody else have any questions? All right. Well, for the sake of time, then I'm going to go ahead on to the next part, and hopefully we'll be able to get to at least our second hands-on activity. So, of course, this doesn't really do much for us unless we can show it to someone else. So when we do analysis, we would like to summarize our results, typically in the form of a visualization. And to do that, we're going to use ggplot2. ggplot2 is based off of this textbook that was written, I think, like 1999 or something like that. It's called The Grammar of Graphics, and basically it posits the idea that all plots, no matter which one you're talking about, whether it's a bar plot or a pie chart or what have you, all statistical plots follow a structured and repeatable format. Basically, this is the format. The book posited that every plot has a data layer, so that's the data that makes up the plot. It's got an aesthetic mapping. So this is a way of saying, for example, my x-axis is is column 1, my y-axis is column 2. It's basically a way of saying, how does your data relate to components of a plot? It has geometries, so that's the literal shapes that you use to showcase your data. So it would be bars for a bar plot, or it would be points for a scatter plot. Facets, I'm not going to describe facets. I think it'll make more sense if I just show you that one. Statistics, that's, things such as, t-testing, p-values for, linear correlation, that sort of thing. Coordinates describes for example, your x-axis can be on just normal numeric scale, or it can be on a log scale. It just really, or for example, if you have a pie chart, that would actually be in polar coordinates. So that's what coordinates describes. Then theme describes the appearance of your plot. So that's where you get to actually have some fun and make it look really nice, and really just make it something that could be published in a journal. So ggplot2 is a package in the Tidyverse that is built on this concept of the grammar of graphics, where you can actually control all of these layers to fully customize your plots, how you want them to be, how you want them to look. And GG in ggplot2 stands for grammar of graphics. So it's quite literally based on these principles. So here's an example of a plot that ggplot2 could make. You can see here, this is over the course of a few years, this is the, I guess, average temperature throughout the day. And you can see that it fluctuates with the seasons. So it's a really nice, elegant way to represent that data. This is an example from a paper that I recently was the first author on. And I actually made all of the plots in this paper using ggplot2. This was actually my figure 1. And this is really just to showcase that you can make really high quality publication ready plots in R using ggplot2. So let's talk first about the data layer. So this was our data from before. So I just wanted to recap this. This is how we made our PCT serve. And this is telling us the percentage of females surviving and males surviving aboard the Titanic. So to actually set a data layer for a ggplot, you use the ggplot command, and you set data equal to your data. Kind of self-explanatory there. When you do that, this is the result. So don't forget to keep following along. If you've got these notes open in front of you in RStudio, don't forget to keep following along, particularly at this part, because I think you'll see that this is quite interactive when you do it in RStudio. So I'm actually going to showcase this here. So I've got, this is the line that I was just showing in the PowerPoint. If I run this line in RStudio, oh, my bad. If I run this line in RStudio, it actually pulls up the plots plane over here. So this is really nice because this is a way for you to not only run your analyses, but when you make plots, they're automatically shown in RStudio. So it's just another benefit of using RStudio. But right, so this is just our data layer. There's actually no aesthetic mapping yet and no geometry, so we actually don't see anything. So let's now set our aesthetics. So to set an aesthetic layer, all we do is we add a mapping. And this mapping is the argument we give to ggplot, and we use the AES function to actually create the mapping. So AES stands for aesthetic. And basically what we're saying in here is that we want the x-axis to be mapped to the sex column, and the y-axis to be mapped to the num_sex_survive column. So on our x-axis should be sex, on our y-axis should be num_sex_survive. So when we do that, this is the result. And we can see that it's correctly mapped our data. So now we've mapped sex to the x-axis. We see male and female, because those are the two possibilities in that column. And we also see we've mapped correctly to the y-axis num_sex_survive. So now that has been mapped to our y-axis. So we've now set our aesthetic layer for our plot. But we still don't see anything. We actually won't see anything until we until we add the geometric layer to this. So let's now talk about that. So a nice way to represent data like this would probably be a bar plot. So let's add that here. So the way you do that is by adding this plus sign. This is the exact same thing as the pipe from dplyr, except it's a plus. There's no difference between the two. When you add this plus, you're able to now stack on top of your plot another layer. So we're adding on top of our original plot, we're now stacking on top of that the geometry layer. And to actually add our bar plot geometry, we use this geom_bar command. And we set stat equal to identity. That's just, this is kind of, I don't want to go into why I did that, but just know that when you're doing bar plots like this in ggplot2, you'll have to do that. And if someone wants to ask later on, I'd be happy to explain it, but it's a little bit too complicated to get into for right now. Just know that when you do this, you actually get to now see your bar plot. So this is everything we had before, except now we've actually stacked on top of it the geometry layer. And we can see here now we've got our num_sex survived. You can see the number of females surviving, and then the number of males surviving represented. But actually, we wanted the percentage of sex surviving, not the number of people. We wanted the percentage of females surviving, not the number of females surviving, and so on and so forth with males. So to actually change that, all we have to do is come up here and edit our aesthetic layer, changing it from num_sex_survive to percentage_sex_survive, because that was the column in our data that holds that percentage information. And when we do that, we can now see that it is now represented as percentages. And then the difference between the females and the males in terms of survival becomes a lot starker. Finally, we can edit the theme layer, and this allows us to make the plot really pretty. And I'm not actually going to go through all the things I did to do that here, because that would just take way too long. but I'll go through that in a separate video that I'll put online if anyone's interested in seeing. So this was our before, and this is our after. So this is after I've edited the theme and made it prettier. And I've added things like I've added a title, and I've added coloring, and I've capitalized these labels, and it just looks a lot nicer. This looks like something you could actually potentially publish. All right, so just before we jump in, Simon asked a question, is there a reason you use geom_bar instead of geom_call? And to be honest with you, I've never used geom call. I assume that's probably the right one to use here, but geom bar also works. I personally don't know. So if you know what the difference is, it'd be great if you could post that in the chat. Okay, so go ahead and do hands-on activity number 2. Again, that's in the notes, and I'm going to give 15 minutes for that, and then we can really quickly go through it. Actually, just for the sake of time, let's make that 10 minutes, because there's still a couple more things I want to go through before we break. Oh, and I apologize because I included a couple extra theme problems, but just go ahead and see if you can get up to the add the bar plot geometry problem. If you can get up to that point, I think that'll be good enough for right now. Okay, so let's go ahead and quickly go through this. I seem to have lost my chat. Okay, there it is. All right, so the first part was to group iris by species. That was just simply the group by command, and then the species is the column that we're going to group by. So when we run that, we can see down here that it's grouped it by species. And then I said to find the average sepal length to petal length ratio per species. So that, again, would be grouping it by species and then doing a summarization. And this is actually a little bit more advanced form of summarization, kind of like what Catherine was talking about before, where you're actually going to do what would be potentially considered a mutate, which is to find that ratio, and a summarization all in one step. So we could just call this, I don't know, length ratio is the mean sepal length divided by petal length. So we can see that here now. We've got, for each of our species, we've got the mean ratio of sepal length to petal length. So then I said to pipe that into ggplot2. I'm a little lazy, so I'm just going to copy and paste this here. So I said set x-axis to species, y to ratio column. So perhaps some of you got confused at this part because I didn't show you this before, but anything in the Tidyverse you can use the pipe command with pretty much always. So to take this data and put it into a ggplot, we can actually just pipe it in, and then we don't have to set this data argument anymore because the data was piped into it. So we can just go right to setting the mapping, and we can set mapping equal to AES, x-axis is species, y is our ratio column, which is now called len ratio. And we can see when we plot that, RStudio will throw the plot up here for us. So we can see that the x-axis is the species column, and it contains our 3 species. The y-axis is our ratio column that we created here with our summarize. All right, and then I said add the bar plot geometry. So again, I'm lazy, I'm just going to copy and paste. And I'm going to do geom underscore bar, and then I set stat equal to identity, just like before. So we can see from looking at this plot that Setosa seems to have the largest average sepal length to petal length ratio. If I studied plants, I might really understand what that means, but hopefully you can at least get an idea from this how you can manipulate this data and then analyze it all in one command, because all of this is really just one command. Just because of the pipe, it's continuous from the data all the way to the plotting. So I had a few other things here which I can just show really quickly. So I said set the y-axis label to something. I'm just gonna show this here. So to set the y-axis label, I can use this ylab command, and then I wanted it to be this. So now I'm going to set the y-axis label to that, and we can see that it has actually changed it. I then said color the plot by species. So to do that, we can come over here to our aesthetic mapping and add color equals species. That doesn't look very good, but there you have it. We probably would prefer fill, actually. Fill is probably a better, yeah, that looks a little bit better. Probably meant to say fill there. And then finally, I said set the title. So you can actually do that with this labs command. So labs title is equal to, and then I'm just going to set it to this thing up here that I have in quotations. And now we've got our plot. So we didn't go through any of the theming or any of the ways to make the plot prettier, but I'm going to make another video that you'll be able to watch online where I go through that. And also, I think Tidyverse is going to go through that in a little bit more detail. Okay, so very final part of this, I want to actually show you how you can get into the last two layers, or sorry, the last three layers of plotting with ggplot2. So let's ask a question, right? How does FAIR predict survival? Like, so this is now our socioeconomic indicator. We want to ask the question, does the passenger's fare predict whether or not they're going to survive? You know, i.e., did people who were had cheaper tickets or more expensive tickets, were they more likely to survive? So we ask this here, we get our data, and then we do our ggplot. We set x equal to survive and y equal to fare. But actually, we can already see there's a problem here. So survived is supposed to be 0 or 1, but it's made this continuous axis here. It's not just a 0 or a 1, it's 0.00 all the way through 1.00. And that's actually because we have a data type problem. So if we look at our survived column, and we can see it here by doing this, by doing the select statement for the survived column, we can see that it's considering this data to be a double or a numeric. And because of that, ggplot2 thinks that you're trying to tell it that survived is a continuous variable, where actually it's a categorical variable. It should be either 0 or 1. 0 and 1 aren't continuous, they're discrete. They're either one thing or something else. They're not on a continuous range of numbers. So how do we communicate that to ggplot2? Well, you can actually change your ggplot command to make survived a factor. So if we make survived a factor, now it's going to be discrete. It's going to be either 0 or 1, and ggplot's going to understand that it's a discrete variable. And we can see now that the plot that this outputs has an x-axis that is now discrete. It's either 0 or 1, but it's not continuous like it was before. So this doesn't look the prettiest. We can actually add some labels here. So in the factor, you can add labels such as died and survived. And that way, it's a little bit more appealing. You can see 0 is died and 1 is survived. And now we're probably ready to add our geometry layer, right? So our geometry layer, probably the best one to use here would be a box plot. And that's because we're not dealing with a summarized form of the data now. We're dealing with all those individual data points, asking whether survival for all those individual data points is related to fare price. So when we use a box plot here using the geom box plot command, we can actually see that this data is well represented by a box plot. But there's still a problem. Our data seems to be very kind of squished here down at the bottom. It's kind of squished here, and then it's there's too much space at the top. And that's because our data could probably be better represented by a logarithmic y-axis. So Simon just asked, would changing the survived column to a Boolean make the ggplot axis discrete too? And yeah, it absolutely would. That would be another way to handle it for sure. So our y-axis should probably be in log scale. So let's now use the coordinates layer of our plot to convert it. So the way we're going to do this is we're just going to add another plus sign and add the command scale y log 10. And all that's going to do is it's going to scale our y-axis on a logarithmic scale. And this just looks a lot better already. So now it's much easier to see the difference between died and survived groups based on fare price. So we can already kind of see that it seems like those who survived typically paid a higher fare price. So we might want to ask another question though, and we're going to use facets to do it. So we want to ask the question, is age a confounding variable here? So what we're going to do is we're going to take all of our passengers and assign them to one of three brackets. They're either children, adults, or seniors. And we can actually do that with a mutate statement in dplyr. So I'm going to go a little bit quickly through this. Come back and visit this if you are interested in using this again in the future. But it's just a really handy way to make that if statement. So basically, if else in dplyr is called case_when. And that means if else when you're doing a mutate. So basically, we're saying case when. If age is greater than 60, that person is then a senior. And then the tilde means if age is greater than 60, then they're a senior. If age is less than 16, then they're a child. And if none of those things are true, basically else, our else statement is what we're saying here, else they're an adult. So this is a bit of a confusing way to show this. I personally prefer using if-else statements to using this because this is a little bit counterintuitive. But just so you can see how you would do this in dplyr, this would be equivalent to having just a long if-else statement for every passenger. Okay, so now we've assigned all of our passengers to one of these three groups based on their age. And now we want to ask, does that have an impact on whether or not we see an interaction between survival and fair price? Because we might think that, well, all right, maybe there's a senior discount, or maybe children pay a flat rate, so it doesn't matter what their ticket prices are as much. So we add another plus, and now we can use what's called a facet wrap. And we're saying facet wrap by age bracket. And I know this probably doesn't make a lot of sense yet. Let's just take a look at what this does. Okay, so this is what a facet wrap is. We've taken our data and we have now split it by some categorical variable. Our categories are now adult, child, or senior. And we've taken our data from the plot and we split it into these three groups to see if in one of our groups there's a difference in the effect of fair price or in the interaction between fair price and survival. So we can see that for adults, the higher the fair price seems to predict a better chance of survival. But that's actually not true for the children. If anything, it seems to be the opposite. And then for the seniors, there really seems to be no difference. Okay, so I know I've covered a lot, but I have one more thing to go over, and that's the final layer, which is the stats layer. So we want to ask the question, first, make sure you load up ggpubr if you haven't already. So basically, we want to ask the question, in our different brackets, is there a significant difference between those who died and those who survived with respect to fair price? So that's like saying, is this difference between these groups, is that significant? Is this significant? Is this significant? And we can use ggpubr to do that. And you can see here what we do to add that test, and we're going to use a t-test. If any of you have heard of a student's t-test, that's what we're doing here. And we use the command stat_compare_means to do this. So I know I've shown a lot today. I think it's quite satisfying. So I just want to get to the point where I think you're going to understand why we want to do all this. So I add my t-test, and now I can see for each of my three facets, is there a significant difference? Well, for the adults, the t-test p-value is less than 2.2 times 10 to the negative 16th. So yeah, I'd say so. That's quite significantly different. But actually, even though it seemed like more children died, that the children who died had a higher fair price, actually the difference between these isn't significant based on our p-value. And there's no difference for the seniors, just like we thought. So it's only for the adults that there's a significant increase in the amount of fare paid by those who survived. So it's only for the adults where your fair price is really relevant to your survival. So after we do some beautification, we can now see what our final product looks like. So the steps in the notes actually show you how to get to this point, and I'm going to go through this in the video. But I just want to show you, why would you want to do this? Well, because you can get a really beautiful ggplot visualization of your data right from within R. I don't have to take this and put it into Illustrator. I don't have to go and manually add significant stars myself. ggplot is going to calculate all of that and output this figure. And so this is why I personally use ggplot and why I think ggplot is going to be a really great tool for you to learn to begin your bioinformatics and your data science experience. Okay, so before I ask if there are any questions, just to wrap up, the homework is to do the Introduction to Tidyverse data camp course, and then do the practice problems for week 4. Do send me your practice problems for week 2. I'm not going to give the answers until you send me those, and I'm going to do a review at some point, probably just make a video and put it online that you'll be able to see, where I go through all of those in detail. So I'll probably do that next week. So if you haven't finished it yet, try to finish it, send that to me, but I'll put that up next week for those of you who just want to check your answers. Okay, are there any questions? Okay. All right, well then next time is going to be Victoria Aller. She's going to be presenting on how to use these skills to analyze qPCR data and just do some sort of fundamental kind of basic bioinformatics before we jump into RNAseq 2 weeks from now. So make sure you're going to office hours and asking if you need any help. And yeah, we'll see you next time. All right, thanks everyone.